right, welcome back. We're going to continue talking about different types of t-tests. This lesson focuses on our dependent samples t-test. A dependent samples t-test is when observations from one sample are related in some way to the observations in the comparison sample. Luckily, the steps to running a dependent samples t-test are very similar to the z-test and the single sample t-test. There are just a few changes that we'll look at. So when do we use a dependent samples t-test? The most common you'll see is in a repeated measures design. And this is typically some sort of pre-test, post-test. Especially in education, we a lot of times are looking at kids or adults pre-test, post-test. We want to see how they are on some characteristic to start with, and then we want to see how they are at the end of whatever time period or intervention we're providing. Occasionally, you'll see the second type, the matched subjects design. This happens when you have, as the researcher, worked very hard to match your two samples to where it's almost as if you were using the same people on both occasions because your participants are so closely matched. But again, we almost always see this as a repeated measures design or pre-test, post-test design. I'll show you the formula, but you know that we won't be calculating it by hand. We will move over to the data analysis software, SPSS. It is similar to the independent samples t-test. So we'll look at that in a couple of minutes. But for a dependent samples t-test, what we're looking at is occasion 1 and occasion 2. Right? Here's sample 1, pre-test, and then sample 2, post-test. And then instead of having one estimation of the standard error, we're having 2, and we divide and we subtract. All right, so the way we would calculate that is here, which looks a little bit intimidating, but if we really get into it, it's the standard deviation of the pre-test plus the standard deviation of the post-test minus 2 times R, or the correlation that we talked about before between sample 1 and sample 2, or pre-test, post-test, multiplied by the standard deviation of sample 1 and sample 2. I'm sorry, these were variance. I think I said standard deviation. If we take the square root of that after dividing by the sample size, then we'll get this. That's pretty complicated, isn't it? So we're glad that we have SPSS and we don't have to calculate it by hand. I like to think about before they had computers and people were doing their research and they wanted to use a dependent samples t-test or something else. All the hand calculations they had to go through, just wow. But I'll tell you what, if you do the hand calculations, it really gives you a deeper understanding of what's going on in the statistic, because you know exactly what's happening to get this t-value and what all is involved. And so, of course, we don't calculate these by hand, but I can see the value in it for sure. So let's look at it through an example. Dependent samples t-test example. So a forensic psychologist wants to determine whether physical exercise in a boot camp program has an effect on muscular strength. He or she measures the number of pull-ups 25 program participants complete at the beginning of the program and at the end. And we have a little information there. So in the beginning, they completed on average 3.28 pull-ups, standard deviation of 1.88, and at the end they completed 3.6 pull-ups on average with a standard deviation of 1.73. So from this information, it's making me think back to the formula where we have the two means, the pre-test, post-test. For the standard error, we have the standard deviation, so we could get the variance we'd have to ask it for the Pearson R, that correlation. And we know the sample size, right? 25. So anyway, we could do it by hand. The number of samples we have is 2. The nature of the samples, they are dependent. We have the same subjects on the pre-test and the post-test. So we have the same participants being measured on number of pull-ups. So our independent variable is participation in a boot camp. Remember, the independent variable is, what does the researcher do? What do you manipulate? Well, in this case, we had people go through a boot camp. And that manipulation is going to impact our dependent variable. So the number of pull-ups depends on participation in a boot camp. Or I should say, that is what we're trying to find out. Does the number of pull-ups depend on whether they participated? So we'll see. So this is a dependent variable, pre and post participation. And then our target population, who do we want to generalize these results to? All boot camp participants represented by the sample. So going through the process that we have started with the z-test and the single sample t-test, the null hypothesis in this case looks a tiny bit different in that we are hypothesizing that the difference pre and post test is equal to 0. All right, so we're saying it makes no difference whether you participated in the boot camp, right? So we're still thinking of no effect, no difference, no relationship. When you're thinking about the null, it's still that kind of nothing's going on mentality. Now, it's a little bit different from the single sample and the z-test, because now we're not comparing our sample to a population. Now we're comparing our sample to our sample. So we're saying, hey, pre to post test, there's no difference. That's what our null is saying. The alternative, we have a non-directional, and it's saying, yeah, there will be a difference pre to post. I'm not really specifying if they're going to do better on the post test, but I am saying they will perform differently. That's what I'm hypothesizing. I set my level of significance beforehand at the very standard 0.05. Then I would run the test. What you come out with is obtained test statistic of negative 1.693, right? And so here, I don't have all the information listed, but if we looked up the critical, the t-critical, we would find a situation where we failed to reject the null hypothesis. So this decision is letting us know that we aren't thinking that our hypothesis is wrong. We are saying there really are no differences. So we're failing to reject the null. Our degrees of freedom, I just made a note of it here, so that if you want to, and you probably should, just for practice, go back to the back of your textbook, look in the t-table. You would look under 24 degrees of freedom, find the t-critical, and compare it to our t-calculated. And what you're going to find is the t-critical is further out into the tail. Because remember, that t-critical value comes from the value at a certain alpha level. So when you go back to the table and you look at it, you're going to have to decide the alpha level, 0.05, and that's going to tell you where in the table. So at 0.05 probability or alpha level, 24 degrees of freedom, what would that t-critical be? Take your t-critical, compare it to your t-calculated here. And in order to find significance, we need our t-calculated to be further out in the tail, because that's going to correspond to a probability of less than 0.05. But our t-calculated here is actually closer or further in than the t-critical. So we're failing to reject the null. There are not differences pre to post test. And I know I just kind of ran through that. We are going to look at it on SPSS. If we were to type up the results for this, we would say the results of the dependent samples t-test to determine whether participating in a physical exercise program increases muscular strength as measured by number of pull-ups, failed to indicate statistical significance. All right, and so here's that same information we pulled before. Excuse me, for the one sample t-test, we still have our t at 24 degrees of freedom was equal to that negative 1.693 at the p is less than 0.05 level. Okay, so it was not statistically significant. If you were to take out the at the, you could put a comma right here and just say p was greater than 0.05. But this is also correct either way. All right. In the discussion section, you kind of give it that qualitative interpretation of, well, they really didn't perform differently as far as pull-ups go pre to post test, at least not statistically significantly different, right? I mean, clearly the before and after values, let me scroll back up here because I think it's kind of, let's see, where is it? Oh, there it is. Okay, so obviously in our mind we can see that 3.28 is different from 3.6, but what the dependent samples t-test allows us to do is say, yeah, there are differences, but they're not statistically significantly different, or the likelihood we would have gotten the mean difference we got if the null is true is pretty big, at least is bigger than our cutoff value, and so we're going to declare our null is probably true. All right, so our next video will be walking through an SPSS example and talking about how to click your way through it, and then how also to interpret the results.